We'll be analyzing air quality over the years using an EPA annual air quality summary dataset from 1980 to 2017. This dataset has nearly 2 million entries, which consist of nearly 1,000 different parameters, which include pollutant and contaminant concentrations, temperature, humidity, and other atmospheric compound concentrations. These measurements were taken at sites all across the US and averaged annually for each site. With the increased consumption of hydrocarbons and fossil fuels in the US over the years, we'll be looking for trends in air quality, whether there is a strong correlation between air quality and time, or perhaps if advancements in technology or other factors have led to cleaner air and reduced contaminants. One of the pollutants I wanted to look at was sulfur dioxide concentrations near Laurel, Montana. Uh, Located there, there's a large petroleum refinery just east of Laurel, and refineries are known for producing sulfur dioxide. Sulfur dioxide is a poisonous gas that can cause lung irritation or even permanent lung damage during prolonged exposure to high concentrations, and it's even known to cause birth defects. As far as environmental effects, this is the gas that forms acid rain, which can cause deforestation, acidify waterways, and kill aquatic life. And it can even go as far as corroding building materials. So the recommended air quality standards for this particular gas are less than 0.02 parts per million for annual exposure. So the measurement standard used for this plot was the annual average. And as you can see, this is just east of the Cinex station in Laurel. Starting in the 1980s, you can see that this is in parts per billion. You can see that we were a little above that 20 or 0.02 parts per million limit. And you can see around 1995, we kind of start having a more consistent downhill trend towards zero. And that's because new restrictions were imposed around that time. The other gas I was interested in was hydrogen sulfide, which is a neurotoxic gas that can kill people. It's found naturally in natural gas and crude oil, and they tend to try to flare it off from wells because it can also contaminate water sources and kill wildlife. I chose a site in North Dakota on the Balkan Shale due to the sheer amount of drilling there to investigate this one a little bit. As you can see, long term, there wasn't nearly as much of a trend as there was with the sulfur dioxide, but this measurement is in parts per million times 1,000, and generally toxic levels are considered above 20 parts per million. Since these are such small measurements, it's kind of harder to. I'm not too surprised that there wasn't as much of a noticeable trend because of how precise the equipment would have to be. One other thing to note, obviously I can just adjust this with the slide bar. This is just a quick overview of the UI. I used Lowe's smoothing to kind of just give a general trend line rather than using a line plot. All of the pollutants are selectable, same with the states and the site numbers, which just made this like a really convenient UI for looking at different pollutants that you may have been interested in or areas. So to wrap this up, there were plenty of monitoring sites that showed a lack of a trend, like the North Dakota site, but there were also plenty of others that showed decreasing trends, like the Cinex site. And it actually turns out that CHS, the company that owns that plant, had spent nearly $2 billion as of 2019 trying to make that plant more environmentally friendly. And I think that and the trends with the other sites are an indicator that technology and our consciousness about the environment have helped us kind of get headed in the right direction of reducing pollutants. Thanks for watching. I hope you enjoyed.